So as a bonus task in our task one, we are to given to write the unit test for this client.py file, means to test the get data point and get ratio function, are this function working fine or not. We have to write the test cases. So I wrote the test cases in the client test.py file. Here the test cases is such that we have to define dummy data points like this for ABC stock. This is the price, and these are the details, and for DF which is the price, and these are the details. We have to define the dummy data, and we have to check our program against this dummy data, and we have to see if the generated output of the program is same as the output of the dummy data that we are passing. If these are same, then we can say that our program is running fine. That's it. So in client 3.p file, we have the get receive get data point function. We have to check this. So we wrote the unit test function. In the unit test function, we are passing the dummy data, all the details of this data, and we are testing this test file against the against these functions. And if the generated output is equal to the correct output, then we are saying that it is okay, the program is running, the program means the client PY file is running okay. So we wrote this uh, uh, test file, and here one thing we have to observe that the two functions in this test file, the get data point calculate price, and the here the you can say okay. So and here the get data point calculate price be greater than ask, means these are the function defined here. Here we are covering the condition when price is greater than the top bid price, when the top ask price is greater than top bid price. And here in the second case, we are covering the condition when top ask price is less than the top bid price. You can see here 120.48 or 119.9. That means here the top ask price is less than top bid price, and here the top ask price is greater than top bid price. So we are covering both the conditions. So we have defined two functions, and we are passing the dummy data, and accordingly we are calculating the output and comparing by the asset equal function with the calculated output. If the calculated output is equal, then we can say that the program client at 3 pi is running fine. So but here we can say that the both the function, this function and this function, are using the same asset function, asset equal and asset equal. So we can do one thing, we can use these dummy values here also in the same function also, and we can comment this out. This also works the same. Okay. So because asset function are equal in both the cases, we can use it in the same function. No need to define two functions. Okay. So then if we run this program, then we have a output run ran two tests in 0.00 second, and okay means the calculated output is equal to the correct output. That means our program is running fine. So as our second task, we have to visualize and analyze the share price data. As soon as we run the program, this kind of interface opens, in which we can see different values of the stock at different time. Here is the graphical representation of the data over different timestamps. What is the top of price? But we have one problem here. We have to click the start streaming button every time to get the updated values of the stocks. We have to click the start streaming data button multiple times to get the updated values of the stock. Yes, so we want to change this function. So we want to automate this process. Means once we click the start streaming data button, automatically the current values of the stocks are updated, so that no need to press the button every time to get the updated values of the stocks. And the same is here. We have to automate this graph. Automatically, this graph should render instead of every time we have to click the start streaming data button to render the graph according to the current values. That means the graph will automatically render the current values after clicking the start streaming data button. And one more problem is there, as you can see here, there are duplicate data and we have to remove the duplicate data. As you can see here in ABC, the duplicate in ABC always the values are same. In for DF stock every time the values are same. So we have to remove the duplicate data by taking the average over the timestamp within which the data are duplicate. And so, because showing the duplicate data doesn't make any sense repeatedly, we cannot show the duplicate data because that is not useful at all. So now comes the solution part. What we want is for the button issue. Initially there is no graph once or there is no values, and if we click on the uh, button once, then the values should render automatically. We don't need to click the button many times to update the to get the updated values. So for this purpose, we have to declare a variable of boolean type, which is true or false. If that is true, we will show the graph or show the values, or if that is false, we will not show the graph or the values. So here in the iState interface, we are declaring uh, a boolean variable show graph. When the show graph is true, the graph will be rendered, and when the show graph is false, the graph will be not rendered. So initially we are giving show graph is equal to false. Means initially there is no rendering of the graph. As soon as we click the button, the show graph becomes true, and the graph is rendered. So in the render graph function, we are checking whether the show graph is true or false. That means we are checking whether the button is clicked or not. If we click the button, then the show graph becomes true. Initially, it is false. That means initially we are not showing any graph. As soon as we click the button, then the show graph become true and the graph is rendered. So now we finish the button click issue. Then we have to render the graph continuously. For this, we have a function like set interval function in JavaScript, which in the interval function, the callback function we have to declare here, and the callback function runs continuously according to the time we given. So here we are given 100. That means at every 100 millisecond the graph should be updated. Here we are giving 100 millisecond, and for each 100 millisecond the graph should be updated. So here we are rendering the graph each 100 millisecond. That means each 100 millisecond the graph should take the values from the server, and it should render in the front end. So by this thing we have solved the two problems. One is the button click problem, and one is the updating graph problem. And now here comes the rendering part. For that we have to modify something in the graph.tsx file. In the graph we have to make some changes in the graph.tsx file. Here we want our perspective viewer element to behave as a HTML element, so that we are extending it to the HTML element. Then we have to make some then we have to make some changes in the component date-mode method, because component date-mode method runs after the component is rendered in the DOM. Like if a component is like the graph component, after it rendered in the DOM, it has to be updated continuously according to the values from the server, updated values from the server. The component date mount, as we have to update the graph every 100 millisecond, we have to change the state of the component every 100 millisecond. So we have to make some changes in the component date mount method. So for better rendering of the graph, for this purpose we are assigning some attributes here, that in view attribute, column pivot attribute, row pivot attribute, columns attribute. What the view attribute does, that in the graph we can see that we have multiple graph to show, like y bar graph, x bar graph, y line graph, this type of graph. But we want only y line graph by default. We can change that, but we want a y line graph by default, so we are assigning view to the y line graph, and Column pivots is responsible for defining the different stocks differently. That means if you can see here, for ABC this is the symbol, for DF this is there is a different color. That thing is done by that thing is done by the column pivot attribute, and there is something like row pivot is responsible for this timestamp. If we remove the row pivot, then this timestamp will go away, and if we remove the uh, column pivot, then this thing will go away, ABC or DF. That means we cannot distinguish between the two stocks. And then coming to the columns has top ask price. That means here the top ask price, the y axis is the top ask price axis, that is defined by the column thing, the column attribute. And then aggregate. And here comes the duplicate issue, because we have to initially we discussed that we have to remove the duplicate data, as this is as the duplicate values are not useful for us. That's why we are using aggregate. And here comes the aggregate function. What the aggregate function does is, it if the values are duplicate, as we discussed earlier, we have to remove the duplicate values also. That's why we are setting this attribute aggregate. What this aggregate does is that when we have duplicate values, it takes the average of the duplicate values in the timestamp, shows it in the graph. The aggregate value is responsible for eliminating the duplicate values in the graph. After applying all these changes, we can see that here we can see in the graph, once we click the start streaming data function, automatically this graph is rendered. And here you can see that there is no duplicate data like the previous one. Here we have a lot of duplicate data, but here there is no such duplicate data. So one issue is solved, we have no duplicate data, and the other issue is automatically it is rendered. So that means we don't need to click the button every time to render the updated data. And coming to task 3, we have the task to visualize and analyze the share price data, display data visually for traders. In the task 3, at the end of the task 2, what we have is we have this graph. That means when we click this button, this graph is rendered automatically, and we no need to click this button every time to render this graph. That means this graph is updated continuously every 100 milliseconds. Here in task 3, we are here to take our visualization to the next level. But what we want to do is, we want to track the ratio of the two different stocks over time, rather than just showing the individual prices over time, because the traders want to monitor the ratio of the two stocks rather than just see the uh, top ask price of the two stocks as in our task 2, because the historical correlation between the two stocks against the lower and upper bound determines a trading opportunity. That means if the ratio of the two stocks is beyond certain point or below certain point, so here, along with showing the ratio between the two stocks, one more thing we have to do. So here one more thing we have to show the upper threshold value and the lower threshold value. That means when the ratio between the two stocks goes below the lower threshold value or goes above the upper threshold values, that determines the trading opportunity. So two things we have to add here. First, we have to show the ratio instead of showing the top ask price of the individual stocks, and again we have to add the top threshold and the lower threshold. That means we have to add the lower threshold and the upper threshold. To achieve these things, we have to make some changes in the graph.tsx file. Here, as you can see, previously in the schema only stock, ask price, and the time stamp were there. So in the schema we have to add some more things like the ratio and the lower bound and the upper bound and the triggering alert. So we have added these things here, that ratio we have added upper bound, lower bound, and the trigger alert. Trigger alert is fired when the ratio is beyond the is above the upper bound or below the lower bound. We have mentioned price ABC price DA because to calculate ratio we need the price ABC price DA. That's why we are keeping price ABC price DA here. Otherwise there is no need to show in the graph the price ABC price DA. But to calculate the ratio we are assigning in the schema the price ABC and price DA. Next, to configure our graph, we need to add some attributes here because here in the previous task we have added these attributes, but in this task, according to the requirements, like we need the ratio, we need the upper threshold, we need the lower threshold. Accordingly, we have to change this attribute. This is in the component date mount meter. Component date mount meter runs after the component is mounted or rendered in the DOM. So as we are changing it every 100 millisecond, we are changing the component every millisecond. We are changing the data every millisecond. So we need to run this every 100 millisecond. So we are assigning some extra elements here or extra attributes here. As you can see here, we are as you can see here we are assigning some extra elements like ratio, upper bound, lower bound, and triggering alert. Along with that, in the y-axis, that means in the column, we are assigning earlier we are assigning only the top ask price in the column, but here we are assigning the top ratio, lower bound, upper bound, and triggering alert. And all these and all the other things are same as per the task 2, but in the aggregate in the aggregate attribute we are adding some extra attribute like a ratio, upper bound, lower bound, and triggering alert. And now we have to make some changes in the data manipulator.tsp. This file is responsible for processing the data that is coming from the server. Here we can see the server response. Here we are processing the data that is coming from the server. So because we are changing some we are adding some attributes like ratio and top bound or upper bound and lower bound, we have to declare it here. So the same thing we did here. We have price ABC, price TF, ratio, upper bound, lower bound, and trigger alert as we have discussed before. As we have added some attributes in the interface, we have to initialize those things here. We have to declare those things in the data manipulator of a class. So what this generate row function does is that it returns the process data accordingly the graph is rendered. So for that thing, as we have added some extra attributes, we have to change means this is the before and this is the after. We have to change we have to change something here. So we had added the upper bound, lower bound, and the ratio field here, like you can see. And in the upper bound we are achieving like plus or minus 5%. This thing we can fix like plus or minus 2%, 3%, 10%, whatever we can assume, but here we are taking plus or minus 5%. And after defining all these things, we are returning price ABC, price TF, ratio, and timestamp, upper bound, lower bound, and triggering alert. Yes, triggering alert. What it does is when the ratio is greater than upper bound, then it raises a trigger alert. Or when the ratio is lower than lower bound, it raises a trigger alert. That's why your logical OR is applied. It means when this condition is true or this condition is true, when this condition is true or this condition is true, then we are raising the triggering alert. That means when the ratio is greater than upper bound and the ratio is less than lower bound, we are raising the trigger alert. So for that thing we are using or logical or here. And when these things are not satisfied, these conditions are not satisfied, we are just returning undefined. We are just returning undefined but trigger alert. That means, as you know, the table.update method takes an array as an argument, but in the data manipulator class, the generate row function returns an object. So this is the object. So this is the object, but the table.update method takes an array as an argument. So we have to convert the object into array. So we added an square braces so that the object is converted to the array of object. So with this we have completed the modification. First what we did was we added some extra features in the schema, and then we have added some extra attributes here accordingly to the schema, and then we have changed some uh, uh, and accordingly we have changed the variables in the interface, and accordingly we are initializing those, and we are returning those variables, and those variables are uh, uh, and those variables are uh, given as an attribute to the update function so that it is shown in the graph. So after this we are completed everything, and our graph looks like this. Yeah, our graph looks like this, and here in the y-axis we are triggering alert ratio lower bound upper bound. This is the upper bound 1.05 because uh, we have added plus and minus 5% to the threshold, and here in this it is timestamp, and when the ratio goes below the lower bound or goes above the upper bound, a triggering alert is generated. That is shown in the red line here. That here we can show that triggering alert is in the red line, and the upper bound is the green line, lower bound is the yellow line, and the ratio is in the blue lines. So the we have completed our all the uh, so we have solved all the issues. One of our issue was we have to show the ratio here. Here is the ratio, and the other thing is other and the other thing was we have to show the lower bound and upper bound, and we have to raise a triggering alert when the ratio is below the lower bound and above the upper bound. Here we have achieved both. Here is the ratio, here is the upper bound, and here is the lower bound, and a triggering alert is there when it crosses the lower bound, or it crosses the upper bound. So coming to task 4, that the last task of the module 1, we have to do an open source contribution. As for the instruction, we can contribute to any of the JPMC open source tool. As we have used perspective, so I thought that I can contribute to the perspective issue. This is the issue page of perspective, as you can see. So for me, the issue in the perspective was a little bit tough to be completed in 7 days, because we have to go through the huge code base, and we have to understand the huge code base along with the understand the issues as well, and along with that we have to come up with a solution to solution by changing the code. So the issues here, for me at least, it seems that it cannot be done in 7 days. At least for me, the issues are not that simple in the perspective. So what I did was I searched another open source in the JPMC itself. So these are the open source in the open source projects in the JPMC. I found the Quorum Remix project, which code base was not that humongous and whose issues were not that difficult, like the perspective one. So I have tried solving this issue like this. I have tried improve error message designing issue. As you can see in my repo, I have this is my repo, and in my repo I have forked the quorum remix, and here I had to solve and here I had to solve the improve error message design issue. This is the simple error message, and the issue was the whenever wherever maybe the error happens, the error message is always at the top, and I have to change the location of the error message according to the block where the error happens. What I did was I initially So what I did was, according to the documentation getting started or development setup, I have set up my environment in the local machine, and then I found some error. Even you can see I have messaged the mentor here, means the repo mentor here, that here my message that is done 6 days ago. The Here I had some message, so I texted him, and he was very kind enough to reply me back after 5 to 6 minutes with some solutions. So I applied the changes and I have contacted him for some further issues. This is giving some error. As you can see, I have commented this. This is the screenshot of my laptop. Here the remix ID was giving some error here, because I have done everything correctly as per his instruction and the documentation available. But after that also there was some error here, so that so I texted him and with the screenshot about the error, and again he replied me with the solution. And uh, then uh, then after this message he replied me with a solution, with a very long solution and a different solution that is not in the docs. So I have applied everything. But again the error came that the for quorum wizard the grep is not recognized. The grep is Unix command that is for Linux only, but my laptop runs on Windows 10, so that's why I, I could not uh, install the dependencies. That's why the whole setup could not be run in my laptop. So he replied with a message that Quorum doesn't work generally on Windows because it uses Unix sockets heavily. And I have tried in Windows subsystem for Linux also, but that also didn't work. And he also mentioned here somewhere here that who is yeah, even in Windows subsystem for Linux also this doesn't work. So therefore the widget also doesn't support Windows right now. So that is a uh, that is a big issue for me, because from the last 6 days I am working on that thing. Well, here you can say 6 days ago, and here you can say 22 hours ago I have I have sent him some issues, and he replied back with this big documentation that is exclusive, because that is not available in the docs or in the Google also. So after doing all these things, uh, the issue came was in the Windows system it cannot be worked. So it is very much unfortunate for me, because from the last 6 days I am working on this, uh, but it cannot be completed because my system is Windows and this thing cannot work in Windows. So that's why I have raised an issue. That's why I raised one issue here, that quorum with their support for Windows. This issue was uh, generated by me only. Here you can say this is my logo. So I have generated this issue so that some other uh, technical member of the this quorum remix uh, open source community can come and resolve this issue, so that it can be used in the Windows environment as well. And yeah, you can see here that I have raised this issue. And but finally, for only one thing, that this thing cannot work on Windows, I could not complete the thing. So this is the whole thing for the Quorum Remix open source project of JPMC. And one more thing is that if I would know that this thing cannot run on Windows, so I would try some cloud Linux machine on which I would have worked for this project only. But as I came to know about this very late, and it's too late also to create an account in GCP or AWS and to access on Linux machine, and after to install all the dependencies and set the environment, and after that working with the issue. So in this short time I don't think it is possible, at least for me, to uh, set up a cloud Linux machine and work there. So if there are more time, then I can say that uh, I could work on this issue and resolve this issue. So that is all about it.